Hello everyone, uh, JCE Connect. I welcome you all for this particular lecture. Again, this is a continuation of tension members. So in that, in today's lecture, I will be solving a problem on welded connection. That to analysis problem. Analysis problem means the sections will be given here, and for that section you have to calculate the strength. That is strength of member. So here the problem given as determine the tensile strength of a roof truss diagonal 100 by 75 by 6 mm. The yield stress of that material is 250 MPa connected to the gusset plate by 4 mm weld as shown in the figure. So this is the problem given, and the figure is also given. This is the figure given. I think you can see this figure. This is the figure given here. So this is the gusset plate. This is the gusset plate. And this is the gusset plate. Let us take gusset plate 8 mm thick. 8 mm thick gusset plate. And this is the angle section of 100 by 75 by 6 mm thickness. 100 by 75 by 6 mm angle thickness. And this CXX and EXX, CXX and EXX, this you will get from the steel table. You have to refer this, you have to refer the steel table. And the length of the weld applied is given. This side is 140 mm. Let us take this length as a L2, and this side as a 310 mm. Length of the weld is given, and this side is 100 mm weld. Okay, so here the length of the weld will be given, the angle section will be given. So for this you have to calculate the strength of the member. So this is the centroid, this one, this you have to calculate strength T, you have to calculate. Okay, so for this what is been given here, so here you can see this one. So from the steel table, for angle, that is a single angle 100 by 75 by 6, you have to get the properties from the steel table. You refer steel table and get the properties. That to unequal angle, just I'll show you this one, 100 by here. So you can see the steel table, 100 by this one, 100 by 75 by 6 mm, and the sectional area is that, just take the sectional area, and as well as CXX and EXX. CXX is 30.1 and EXX is 69.9. just these two also you note it down. So these two represents the centroid of the section. Okay, so for 100 by 75 by 6, note down the sectional area, then the CXX and EXX also note it down. So here they are marked which is to be taken as CXX from the heel to the center, that is CXX, and CXX next EXX from the center to the extreme fiber distance. This is extreme fiber distance they given here. See, you can see here they mention center of gravity. This is, can you see this one? Center of gravity, this one, center of gravity, CXX and CYY, EXX and EYY, that is distance of extreme fiber in this figure. So here mentioned CXX and EXX. This is from the heel to the center is a CXX measuring from x-axis, and from the center to the extreme fiber distance is EXX. If you are measuring from the y-axis, that becomes CYY, EYY. So you refer a steel table and get the properties of that angle section. That is gross area 10.14, that is 1014 mm square, then CXX, EXX, and mark in this section. Okay, then after marking we know that the tensile strength of member will be the least of the following. So the least of the following means the strength due to cross section yielding TDZ, then the strength due to net section rupture TDN, and the strength due to block shear failure. So the least of these three will be the tensile strength, that is T, the least. So you have to get TDZ, TDN, TDV. Then the least of these three will be what? Tensile strength of the member. So let us calculate the first one. So in that first one is what? Strength due to cross section yielding, TDZ. So for this you can refer page 33 IS 800 2007. And refer page 33 IS 800 2000. You will be getting this formula, TDZ formula. Then substitute all here, you will be getting 230.45 kilonewton. This is TDZ. Next you calculate strength due to net section rupture. So this formula, again the same formula you have to take. So whatever in bolted connection also you have taken the same formula to be taken for a welded connection also here. 0.9 ANC FU divided by gamma L plus beta AGO FI gamma MO. Then here is ANC is a connected leg area, that is this connected leg area. Then AGO is the outstanding leg area. So here ANC and AGO will be connected leg area and gross leg area. Connected leg area means this one. So 100 mm leg is connected here, this leg area, and outstanding is this leg area. Okay, so here this one you have to take 100 minus 6 by 2 into 6, which is 582 mm square. Then outstanding leg is 75 minus 6 by 2 into 6. So how this will come, and I explained in earlier lecture. So please go through that lecture. You will come to know how this 100 minus 6 by 2 and 75 minus 6 by 2 will come. Okay, so after getting this one, then the length of the weld, you have to take the average length of the weld. Okay, so here the length of the weld is given as 140 mm this side and 310 mm. You have to take the average of these two. So that becomes length of the weld, that is LW will be 140 plus 310 divided by 2. You will be getting 225 mm. This is the average length of the weld. That average length you have to take here. So here given 140 plus 310 average length. So in welded length. So after that you know the beta formula, that is correction factor. This formula also it is there in a code. Just note it down, this formula from the code, then substitute all the values in this one. Okay, so here W is the outstanding leg width. Here it is given outstanding leg width, that is 75 mm, thickness of the angle section 6 mm, then yield stress of the material 250, ultimate stress of material 410, PS is the shear leg width W, that is 75 mm, then LW again average length of the weld, that is 225. So when you substitute all, you will get the value of beta, that is 1.206. So it should be less than or equal to the value that is given in this one. So in codebook this 0.9 is not there, but you take this 0.9 multiply by this one, which should be greater than or equal to 0.7. Again gamma MO 1.2, gamma ML 1.25. Suppose if it comes to be greater than or less than 0.7, you have to take it as a 0.7. Okay, so after calculating beta, the next is what? You have to calculate TDN, that is TDN. Substitute all the values in this formula, you will be getting TDN. This is TDN, strength due to rupture. Next is, so here you have to calculate block shear strength. So what has been given here? Since the member is welded to the gusset plate, no net areas are involved. Means here no hole is been made. So in bolted connection the holes are been made. So for that purpose we have been deducted some areas there. So here no question of making any holes, hence no need to deduct the areas here. So that's why the no net areas are involved, and hence AVN and ATN in the equation for TDB should be taken as corresponding gross areas only. So I hope understood this one. Since the member is welded to the gusset plate. No net areas are involved, and hence AVN and ATN in the equation for TDB should be taken as the corresponding gross areas. So here let us take this here, average length of the weld, as we know this is 225 to be taken. Then TDB1, this is the formula you are having in the codebook, AVZ into FI divided by root 3 gamma MO plus 0.9 ATN FU gamma ML. Then TDB2 is what? 0.9 ATN FU divided by gamma MO into root 3, then plus ATN FI divided by gamma MO. Okay, then calculate AVZ. AVZ is what? Shear area. So shear area means this one here, this area to be taken. Shear area means we have to take this area parallel to the load. So for that you have to take the average length of weld multiply by the thickness of gusset plate you have to multiply. So that is to be taken here. Okay. So here given AVZ and AVN both will be equal. So here no question of deducting any areas since here the connection is welded, so no need to deduct any areas here. So AVZ equal to AVN, that is 225 multiplied 8 is the gusset plate thickness. So we are welding to the gusset plate, so gusset plate thickness to be taken here. So multiply it by gusset plate, and you multiply this, you will get this area. Then AT is that is a perpendicular to the load, that is 100 into 8 is the perpendicular area. Okay, so that is the plate is like this. Okay, so this one to be taken perpendicular 100. Okay, this is parallel and this is perpendicular to the load. So 100 into 8, that is 800. So here note given the gusset plate thickness to be taken here. So after calculating ATZ, ATN, AVZ, AVN, substitute in a TDB above equations, we get TDB1 as 708 and TDB2 as 798.38 kilonewton. Then the least of these two value will be TDB, that is design strength of section in block shear or block shear strength. Then finally the tensile strength of roof truss member will be the least of above 3, that is TDZ, TDN and TDP. So now finally you have to check which is the least value in TDZ, TDN, TDP, and that the least value to be considered here, and that becomes the tensile strength of the roof truss member. So this is the way to solve the problem of welded connections. Okay, so I hope you understood this problem, and we'll take a next lecture. We'll take a double angle connected on either side of the gusset plate or on the same side of the gusset plate, and we'll calculate the tensile strength. The only difference you get here, just you have to multiply it by 2 like a bolted connections. So if single angle is given, this no need to multiply by 2, but if the double angle is given, you have to first calculate for one angle strength, then you have to multiply it by 2 for the double angle. Okay, thank you.